Hello everyone, we are from Group 11. First of all, I would like to introduce myself and the others group members. Our group consists of Hanif, Fazli and me Mustaqim. We are assigned to present about the type of solution for system of linear equation, which is unique solution. In linear algebra, whenever we deal with equation and expression, we come across with the phrase unique solution. By the term unique solution, one means to say that only one specific solution set exists for a given equation. So, as you can see now, in the linear system, we have a two, which is non-homogeneous system and homogeneous system. So, the system has a unique solution when the rank of the matrix A is equal to the rank of the augmented matrix and also equal to the number of variables. So, if the coefficient matrix A is an n matrix, then a system of linear equation has unique solution if the determinant of the matrix A is not equal to 0. Or in other words, we can say that it's a non-singular matrix. If the determinant of the matrix A is equal to 0, then there are many solutions or no solution, but we definitely know that it has no unique solution. So we can see from the example, we get a system of linear equation which is x plus y is equal to 1 and x minus y is equal to 3. So the first step is we can write down the system of equation in the metric format, which is ax is equal to b. The A is the coefficient of the matrix, X is the variable of the matrix, and B is the result. From the equation, we can write it is the 1, 1, 1, and the negative 1. So, for the X, the variable of the matrix is only 2, which is X and Y, and the result is 1 and 3. So, there are two methods to find which is the unique solution. So the first method is we can find a determinant of the matrices A, which is we obtain the matrix of A is 1, 1, and 1, negative 1. So we can find the determinant is the 1 multiplied with negative 1 and minus with 1 multiplied with 1, which yield to the determinant of A is equal to negative 2. Since the determinant is not equal to 0, we can conclude that the solution is a unique, or it has a one solution only. So the next method is we can use a rank method. So we can reduce the augmented matrix to reduce row echelon form by elementary row operation and get. So we just write the augmented matrix form, which is 1, 1, 1, 1, negative 1, and 3. So the first step is in this position must will be 0 to make it reduce row echelon form. So we just do some operation in the row 2, which is negative R1 plus R2. In the row 1, we just copy it. So in the row 1, 1, 1, and 1. In the row 2, we make operation negative R1 plus R2, which is negative 1 plus 1 is equal to 0. Negative 1 plus minus 1 is equal to negative 2. And negative 1 plus 3, which is equal to 2. So next, this position must will be 0 to ensure that it allow the reduced row echelon form. So we can easily divide it. The row 2, we can easily divide with negative 1 over 2. So, same as the first step, we just copy the row 1, 1, 1, and 1. So, and the row 2, we divide it with negative 1 over 2. So, 0 divide with negative 1 over 2 is 0. Negative 2 divide with negative 1 over 2 is 1. So, 2 divide with negative 1 over 2 is equal to negative 1. So, the last step is this position must be 0. So, we make operation at the row 1 with negative R2 plus R1. So in the row 2, we just copy it back, which is 0, 1, and negative 1. So in the row 1, we get 0 plus 1 is equal to 1. Negative 1 plus 1 is equal to 0. Negative 1 plus 1 is equal to 2. So from the solution, we get the rank of A is equal to the rank of augmented matrix, which is 1 here and 1 here, is equal to 2. It's also equal to number of unknown, which is x and y. So we can conclude that this solution have a unique solution. So I will give to the Fazli to explain more about the example of unique solution.
Okay, so for the next example B, given an augmented matrix of a system of linear equation in its row echelon form. Okay, This is the augmented matrix, which is the combination of coefficient matrix and constants matrix. And this augmented matrix in its raw echelon form, which is all the leading entries in each of the row, okay, in each of the row are 1. So we have to determine whether this system is unique or not. So we have to solve this system. So we can use a rank method, which is we have to reduce the augmented matrix to reduce the row echelon form by using the row operation. So first of all, we have to make this matrix to become the identity. So we need to change this 2 and 3 to becomes the 0. So first of all, we realize that this row, okay, we have the 1, which is the same column with 2. So we can do the operation to make sure that 2 becomes the 0. So the operation is we multiply this we multiply the row 3 by -2 first. Okay, so we multiply 0 0 0 also 0 1 is -2 and 4 -8. Okay, after we multiply by -2 we plus with row 1. Okay, row 1 here. So 0 plus 1 0, 0 plus 1 is 1, 0 plus 0 is 0, and -2 plus 2 0, and -8 plus 2 is -6. So we got this new row here. So next we have to make sure this 3 becomes 0. So same method, which is we have this one here, same column with the 3. So we can make the operation with this row. So we multiply this whole row by -3. So 0 0 0 multiplied by -3 is 0. 1 become -3, and 4 become -12. Okay, so after that we plus with uh, row 2. Okay, so 0 plus 0 is 0, 0 plus 1 is 1, so -3 plus 3 is 0, and -12 plus 3 is -9. So we got a new row here. Okay, so that's all. Okay, it's done. We have created the identity matrix here. So we got the solution, and then we find that the rank of uh, A matrix same as rank augmented matrix. Also same number of unknown, which is 3. Okay, that's mean the the determinant of both uh, row A, I mean matrix A, and augmented matrix is rank 3, which is the determinant is not equal to 0. And when the both these rank are same of the number of unknowns, thus the solution is unique. So this give x equal to this coefficient equal to this product. There is only one solution. Thus, the solution is unique. That's all. So I will pass. I will pass to the Hanif to another example.
Okay, so uh, for the example for the unique solution system, um, we can get into the page to the page 399 of the book, textbooks engineering mathematics. So we can look at the question. Um, Solve the following system of linear equation by using Gauss elimination method, and we can look that there were 3 variables and we convert it into the matrix shape, and we get this for the matrix shape, and we can tell that the matrix the question has three variables, and also the result is three. So what we do, we just perform the elementary row operation to get an actual matrix. So what we're gonna do is to match this 4 and 3 0. So what we can do is firstly we using an equation which is for the row 2 is minus to 4 times row 1. Row 1. Okay. Row 1. So when we finish that, we can get the number of the matrix is like this. And after that, we use the for the row 3 also, we need to convert 3 into 0. So what we're going to do is we use the row 3 minus 3 times row 1. Is row 3 minus 3 times row 1. Means means if we get we use the number of 3, 3 minus 3 minus by 1, 3 minus 3. So we can get 3 minus 3 equal to 0. So followed by the 1 minus 3, 1 minus 3 multiplied by negative 1, and we can get 4. And of also the number 2 and 33. So we can get of this shape. Okay, so um settle for the row for the column 1. We get this. So after that uh we need to settle this column 2, right, which is we using row 3 also, and minus to 4 times row 2 sorry row 2, and we use this equation to make sure uh this number 4 to convert as a 0. So we need to convert 100 and 10 only. So uh we use this equation to make sure this convert 0. Same method as the this just we change the equation. So after that we get like this matrix, and uh, we we need to change 19 to 1. We need to convert it as 1. So what we're going to do, so we cannot use the minus or plus method again, because it will be affect the other number. So we use divide. So we use this term, which is 1 over 19 for the only row 3. So we can get the one of this method. Okay. So after that, we settle of the row operation and get the ancillary matrix, which is we get 100, and that's all this leading by 1. So we what we get that since the variable equal to the result is B is result, and the system as a unique solution. Okay, so therefore we convert it to the unknown number system shape, which is x minus y plus z equal to 3, y minus 5z equal to negative 6, and z equal to 2. We just use the calculator in simultaneous, so we get this answer: x equal to 5, y equal to 4, and z equal to 2. So that's all for the example. One of the example of the unit solution. Next.
So that's bring us to the end of the presentation. To quickly recap, I would like you to remember this key point. If the rank of both matrix A and augmented matrix is equal and also equal to the number of unknown variable, the system has a unique solution. And the other one, if the matrix A is a non-singular matrix, or in the other word, the determinant of matrix A is not equal to 0, the system is consistent and has a unique solution. On behalf of my group, I would like to say thank you so much for your interest and attention. We hope this presentation can make it easier for you to solve the problem of a system linear equation that has a unique solution. If anyone has any question, please feel free to ask through WhatsApps, and we will do our best to answer it. Thank you.